Hello everyone and welcome to Mechanical Simulation's web demonstration titled VehicleSim 2020.0 New Features. My name is Sherry Walker and I will be the moderator of the demonstration today. Jeremy Miller is the Director of Engineering here and he will be presenting along with help from Mike Sayers.
Okay, move that over.
Yep, go ahead. We will start.
Okay, this is Mike. And this isn't moving, Jeremy. Okay, we're Mechanical Simulation. We have been around for since 1996. We're used by OEMs, Tier 1 suppliers, universities, and we have a few thousand seats out there. We just had a new release of all four of our products, CarSim, TruckSim, BikeSim, and SuspensionSim in mid-December. And that's all I have to say right now. Jeremy, you want to talk about the company for a little bit?
So our company is composed of a couple different disciplines. We have software, computer, and mechanical engineers that all work on product development. We also have artists that provide assets to the simulation tools that we have. We break those up into a couple different teams, as you can see there. We are a pretty small company. I mean, we're growing, we're hiring this year. Our turnover rate has been historically pretty low. We believe in hiring experts and keeping them happy and working on our products.
What's that 13.2 down there?
The 13.2% is the industry average for a software company, their turnover rate. So we're better than half on our turnover.
People here like it.
Yep, that's what those numbers say. Yep, for sure. With our team and with automation that we've added, we're able to release twice a year on time. So we've maintained a 2-release cadence for the past couple of years, as the diagram shows. We have major releases in December and June, which this presentation is about talking the release we just did in December. This is pretty important for our development partners that the cadence is maintained. That way we can work with different companies and they can be sure that we're going to release our products on time, and we can work on interfaces with them on their release cadences. We support quite a few different platforms, and as I mentioned earlier, automation really helps in supporting all those different platforms, especially testing and building.
I'd like to add one thing. Very often with software, when you see a .0, that means that's the major release, and then a .1 is a minor release. But we've, after all these years, we've gone to just every 6 months is a release, and it's the best we've got. So there's no 19.1 isn't better than 19.0 in terms of significance. They're all getting the same amount of development and working there. Of course, I'm not trying to deprecate the 20.0 that we've got now, but if it's more convenient to update in the middle of the year, you're fine doing that.
Mm-hmm. All right, so one of the requests we've gotten quite often is helping customers upgrade their databases between releases. So we admitted that we need to improve in this area in terms of letting the customers know what has been deprecated in terms of screens, what potential problems exist within the database, and what things we have changed between releases, and notifying the customers of those changes. So we added a couple different features. One, we log and report deprecated keywords and the solver logging. We added a new link type to the browser, which you can see on this UI image here, this orange link. We also added the ability to report deprecated assets, or I'm sorry, deprecated screens. And this is available from the Tools menu. You just simply run and it will show you any screen that's been deprecated or is going to be removed from the product eventually. We also added the ability to detect bad links or broken links. Excuse me. Again, that's a tool that's available from the Tools menu, and you can run that on your database. Also, during conversion, we pop up screens or pop up messages to let the users know that the particular screen has been deprecated, And for every screen that we deprecate, we provide technical documentation on how to move to the replacement screen or the screen that's available. And so that's again meant to help the customers upgrade between releases.
You might wonder, why do we deprecate things? And as time has gone on, the models have gotten more complicated. We've added more features. 15 years ago, you could run CarSim on the road, and you could have the driver model follow the path. Now we have, I think, 500 paths that can be in there, and 100, or is it 100 roads?
I thought it was 200.
200 roads? Well, way more roads than you'd need. But in making these changes, as we add more and more features, we'll change keywords to make it more appropriate for all the options that we have in there. And then as we made the programs modular, we improved the way that tables work so that many of our tables can have be functions of two variables, or they can be split. Before that, we might have two tables. For example, the one that's showing on the screen here is for a speed controller. We could have a target speed as a function of time, or we could have it as a function of station. Currently, we have it as a function of both time and station. So the two old libraries of time only or station only are redundant, and we finally have settled them down so that the link that you see in there is orange. That's for one of the libraries that is redundant. There is documentation telling you how to copy your stuff and move it into a new one. Typically, the deprecated keywords and tables we won't use in release for several years, even before it's deprecated. So if you're using anything that you got from us in the last few years, this isn't an issue. But if you're importing stuff from, say, version 9 or version 2018, then this is relevant. And it's extra work, but we're trying to minimize it and get as many notices and automation as we can. So now for new features that are real specific. We've been spending a lot of time in the last few releases improving the powertrain towards electrification. We've always had a good internal combustion engine mapping of things with differentials and transfer cases. We added a hybrid, a Prius type powertrain system a couple releases ago. Then in the next release, we had a pure electric, but you couldn't do all-wheel drive electrics where you might have a hybrid on one side and electric on the other. Now you can. So let's see if I can do this right. Oops. And you said TruckSim?
Mm-hmm.
Okay, this is, Jeremy, you want to get me to the right? Oh, that was easy. Okay, so this is a TruckSim model. We go into the powertrain, and this is the same top-level powertrain model that we've had for a while, but we do have other options up here. We can have the internal combustion, hybrid, electric only, and I think we had that in the last release. The difference, well, first show this. This is the full hybrid thing where you have a planetary gear that connects the either the internal combustion or the electric motor to the rest of the system. This is an electric only version, so we don't have the planetary gear. There is no internal combustion engine. And we have motors that can be on the axles. That's what that was doing. Now, are they on the axles or not? When we go into the differentials here, this looks like the same screen that we've had for a long time for the differential, except down here in the lower left, you've got the option of putting an electric motor there. And all we need to describe that are its torque characteristics and its efficiency. So that was on the front. This is on the rear, so we have electric motors on both. So we have these are all the torques that are being transferred in there, and we've got tons of outputs now. Oops. But these guys, okay.
Yep.
This is the power information, battery. We've got things with battery charging up the flow of power into and out of the battery, and so on. Back to, okay, the driver model. Last year, in the last release, I'm coughing. You want to take over?
Yep. So in the last release, in some of our driver model needs, we identified a couple of parameters that we needed to add to allow for better control. A NIC current path sweep is a parameter that allows a user to define station, especially when they're switching between longer paths. So in previous releases, we would have station be updated by the user when a path switch occurs. This particular parameter allows that station value to be calculated as best we can. It's not a pure mathematical solution, but it gets an answer to the user, especially when switching paths along long segments. Think of a highway merge. XREF and DM front and rear, that is about offsetting the driver model reference point, a distance between the front and the rear. In this particular example we're showing here, it's in the front obviously, and that distance is from the front axle location. We also added YREF DM, that is ability to set this point transversely, left or right, depending if it's front or rear.
Can we look at that cornering thing, the TruckSim?
Yep, that's what I'm bringing up right now. Yep.
It's the PBS one?
Yeah, right. Sorry.
I can
Yep.
talk again?
Okay.
I'll try. Sorry about the cough. One of the things that we've done in the past is support a set of regulatory tests or simulations called PBS, performance-based standard. They're used in Australia and other places to determine whether or not to let trucks on the road. And one of the tests says drive so that the outer front wheel follows a path, a 12.5 meter radius path. We can see that the yellow dashed line is a 12.5 meter path. Our driver model traditionally controlled the center point of the front axle. That would be following the path. Now you see that there's some big angles here between the lead unit, the tractor, and even more with the trailer. So the angle of the vehicle to the path makes it difficult with anything that's based on a point not at that tire. With the new parameters, you can say we're tracking a point right here at the outside of the wheel. The standard says that you have to track it so that it's within, I think, 50 millimeters, which is not trivial, but it's not hard. You put a mirror out there and the driver can be looking at it, and a skilled driver is able to figure that out pretty quick and follow the path. But it can be a hard thing for a simulation to do. So with that new feature, instead of having, we move the reference point over to that exactly. The distance that we preview, we can set that, and it was still a challenging thing to do. And in this TruckSim example, there are some BS commands that change the preview length, and they can also adjust laterally what the position here is. It's been a while. I don't remember if we do them. If you preview too far ahead, you overturn. If you preview too short, you don't turn enough. So it's kind of changing the preview distance based on where, what the current tracking error is. But you see that what we're doing, it's around a little over 20 millimeters is the biggest displacement we get. We had this before using a feature where it would back up in time if it deviated using a thing we call Mr. Wizard. Help Mr. Wizard, I'm not where I want to be. Take me back 3 meters and let me try again. This is a lot simpler. We have some other examples that I won't show where when we're going forward and backwards, we can change that to make it follow paths more specifically. And more on the driver model, it's really some invisible changes that we made that make it more stable when going backwards and configuring it. Let's look at the offset backing here. So we see that there are 2 lanes, the truck. Here's the preview point. I'm going to spin around, so we'll look at this from the back. And this example was made by Dr. David Kline, who is sitting right here. So,
hello.
You want to?
Sure.
You want to drive for a second?
I can. Hi, everyone. So this example is sort of based on how our single point preview driver model works, which was introduced in a previous release. So for this release, what I did is I took the logic that we use for the single point driver model and I extended it to steer the trailer hitch relative to the vehicle. And so what it does is it sets the hitch articulation angle as if it's the front axle of the vehicle. So it steers the vehicle combination by adjusting the hitch articulation angle. So it works logically the same way as our single point driver model, except that with VS commands, it's extended to work with the trailer reversing.
So as we go up now, you can't see the preview point because it's in front. We brake to a stop. There's the preview point you see down right here. We're getting drastic steering up here because it's going to change to a whole new lane.
So the VS commands calculate the desired hitch articulation, and then that is fed into the steering wheel through some control logic. So it uses the built-in controller to drive forward, and then using VS commands, it determines the trailer hitch articulation angle necessary. So it's the same logic as the controller that is used to drive the vehicle forward along a path. It's just been extended with VS commands to work with a trailer backing up.
Now we go back to PowerPoint, Shift F5. So what's showing up here are the XREF, F, and R. Those determine where the preview point or where the reference point is located longitudinally. The default if you're going forward is at the front axle. The default if you're going backwards is at the rear axle. But you might want more. Might want to, if you're interested in a different part of the vehicle, move it somewhere else, as in the case of that 12.5 meter radius turn. And then the YREF lets you, is the second dimension. It can be offset not only for that cornering thing, but for parking simulations if you're very interested in where one corner of the vehicle is to not hit something. That's what you want to track. Did you talk about the path sweep?
I did.
Okay. Okay, the brake transport delay. Since the beginning of our company, we've had a parameter called T-lag BK for each wheel that puts a pure time delay in, and this is noticeable in hydraulic systems, but it's real noticeable in air systems, especially with trailers. The thing is, the way we had it up until now, It only worked if you were specifying the master pressure using a table. And if you're doing that, it's real easy to see what the delay is. You just look at a different point in time on the table. But it did not work if our speed controller was being used, and it did not work if you were receiving the pressure from Simulink. Now it does work, and the person who did that was also Dave Kline. So we do have, wait, you can talk, I'll...
So the way it works now is it stores the master cylinder pressure in a buffer. So no matter how you get the master cylinder pressure, it can access the time history of the master cylinder pressure. So that allows it to place a lag between the master cylinder and the brake actuators on the wheels, regardless of how the master cylinder pressure is specified.
So right down here in this miscellaneous field for this example, David put in that the lag for the front wheels is 0.5 seconds. The lag for the rear wheels is 1 second.
It's worth noting that those T-lag BK parameters were already in existence. It's just that the actual way the feature is implemented has been upgraded to allow those parameters to have meaning in more situations.
They would have been ignored in this example, which has the bus going on something that was imported from Atlas for a public road. It's going up and down hills, and when the speed controller has, right now, it's going down a slight grade. You can see the brake lights here are on, and you see that the pressure here for the wheels is pulsing. They're not all pulsing at the same time. You've got the master cylinder pressure, which goes first, then the brakes on axle 1, then the brakes on axle 2, so that you see three little histories here. And now it's going up a hill, so the brakes are off. Now it gets another downgrade. So this is not an open loop thing. It's being determined dynamically, and it just, those legs would not have been there in past versions. Now they are. Oops, I didn't want to do that, but I did. Oh gosh, here we are again, Dave.
Would you like me to go through this?
Yeah,
Okay. So in CarSim...
we don't have an animation for this, so just
Okay. So
tell us what F-min search is.
Yeah. So in CarSim, I was exploring the idea of what I call a CarSim-based optimization, which is where you treat a CarSim run sort of as a black box problem that is really the function for some kind of optimization algorithm. So in that sense, you can think of CarSim as you give it some parameter and it gives you some cost, like a cost function and an optimization problem. And so what I did is treating CarSim as this sort of cost function in an optimization setting, I added examples that show how you could use MathWorks, MATLAB, fmin search function with CarSim using the VS API. So that allows MATLAB to call a CarSim run using a MATLAB script and just treat CarSim as a function for the fmin search algorithm to find an optimal value. In this case, the parameters I chose as the variables in the optimization problem were those associated with our driver model. And so it allowed the driver model parameters to be varied so that the lap time could find a local minimum. The fmin search algorithm is a type of simplex method that sort of heuristically guarantees a local minimum. But it's still a very useful algorithm when you don't have a lot of detail about the structure of the optimization problem. So it's very useful in a CarSim-based optimization where you don't have access to, say, the derivatives of particular optimization variables with respect to CarSim as a cost function. The other example doesn't require the API or any external software at all. It actually implements an optimization algorithm using just VS commands and events in CarSim. And so it's sort of a naive algorithm that steps in the different independent directions of a problem space to try to find an outcome that's better than before. And again, it's demonstrated with the two driver control parameters. But you could extend these examples to study the effect of any CarSim parameter on a particular output variable. In the next release, we have some ideas about how we can improve the representation of the path along the lines of optimizing certain parameters associated with following a path. So in this release 2020.0, we came up with these examples, and then that gave us some inspiration for some things to work on for the .1 release.
And one thing that I noticed in reviewing the runs afterwards, if you click the run button on one of these, you're going to wait a while.
Yes, these do take a long time to run because, like the fmin search example, for instance, it will call the CarSim run hundreds of times, if not thousands of times, depending on how you have it set up. So I think on my PC, these take about 15 minutes to run each, these examples. So,
but you can see the result with just by clicking the video and plot.
Yes, yes.
Okay, don't go away, Dave. Much of Dave's time was spent reviewing SuspensionSim. We've got some new examples in there, and go to look at one of those. Isn't that SuspensionSim?
Yeah. Just restart it.
Okay. Okay, let's. We've been getting requests for years to have a leaf spring model in here. And an issue is that a good leaf spring model is very hard to do. This isn't a good one, but it's better than nothing. It's a finite element model in one sense, but there are only 3 elements. It's a SuspensionSim is strictly a rigid body tool. But this came from a SAE standard?
Yes, this approximation for the jounce kinematics of a leaf spring rear suspension goes back all the way to like the 1920s with the SAE Spring Committee. And so this was published in various forms in SAE spring design manuals for a number of years. I think the actual manual is now out of print, but it's basically a way to approximate simply the jounce or up and down motion of the axle by treating the leaf spring as a 4 links with some compliances in between the links. And so this model is useful for generating the jounce kinematics. So say how the axle steers or moves longitudinally just as it moves up and down purely. This model does not give you any kind of roll information or compliance information. However, it is an implementation of an industry standard approximation, and it is useful for generating certain input data sets for CarSim and TruckSim.
Now the real improvement, the real change that was made to the software is the part of SuspensionSim that does the calculations. And the way that it handles rotations is fundamentally different than the way that rotations are handled in our vehicle models. They use Euler angles so that, for example, with the sprung mass, first you yaw it, and then you pitch it, and then you roll it. And we output those angles, but if we were to pitch it and then roll it and then yaw it, we could do that to get to the same place, but the angles would be different, the values, because the sequence is important. SuspensionSim used a method where it would get to the same place, but the order didn't matter. Is that right?
It represents the orientation of a rigid body with an axis and an angle, fundamentally. So it's just one axis, one angle for any given rotation. And we studied the solver over the last 6 months, and we determined that there were cases where you could get an inaccurate value. And what would happen is if you had 2 bodies in SuspensionSim that changed their orientation a large amount, the relative orientation between the 2 bodies would be inaccurate. It would be sort of a linear approximation of a problem that isn't linear. And so for examples that involve 2 two bodies in SuspensionSim that are both moving a significant amount relative to ground, the relative orientation is now more accurate. So like if you wanted to output orientation in a ball joint, which is between a moving wheel and a moving lower control arm, that value will now be more accurate.
Okay, we actually did a lot of work on BikeSim, and if you're a BikeSim user, you'll hardly see it, which is good because we changed the architecture completely in the same way that we changed CarSim and TruckSim in the last few years. So the two the two Windows things over here, the one on the left is showing all the DLLs that were in BikeSim 19.1. There were 12. 6 for 32-bit and 6 for 64-bit. Now there's just two, one for 32 and one for 64. The old one had customized solvers for things like, does it have 2 wheels or 3 wheels? Is the a rigid caster or a variable caster in front? Do we have flexibility in the front or rigid? So we had 6 possible combinations, and therefore 6 completely sets of source code for them. Now they have been modularized, so there's just one BikeSim that supports all 6. And there are a few benefits from this that you see right now. We have better connectivity if you're running with outside software such as Simulink. We have something called kinematical preview that we've had in CarSim and TruckSim for the last few years. The command was there in BikeSim, but it wasn't very effective because the old architecture didn't separate the kinematics with the dynamic equations. Now they are. The echo files have been changed so that they're much more organized in the same fashion as CarSim and TruckSim, and they have a few more output, a few more calculated variables in there, like the total mass inertias and for the entire vehicle. The main thing that we'll be seeing is in future releases, we've had requests that have been on hold until we got through this step. Now this step is done and we can start adding new modeling options. Ooh, VS Terrain. Now, the history of our ground modeling capabilities, when the company started, we just had a grid of X, Y, Z data. And then around 2001, we added roads, which were using a curved rectangular grid kind of concept for the road. And we had the path that the driver model could follow. As mentioned before, we're now up to several hundred roads and paths that are in there. But it does get complicated, and there are other sources of data. If you are using the LiDAR scanning kind of thing, that gives you a single mesh, a whole bunch of triangles that define the surface. If you're the game people will have artists put together environments, and Jeremy here is a former game guy who did a lot of the road stuff in VF Pro, and now he's not doing this, but other people from the company he was formerly with are doing some of our 3D graphics. We have a new option called VS Terrain that was introduced a few years ago, and we've been making major improvements on that with each release.
More? Okay. So some of those things that Mike had mentioned is especially powerful is the free-formed structures that you can set up in a gaming or 3D Studio Max or Maya types of programs. So this allows the artist to be completely free-form, no strong tie-in to any type of parametric roads or anything like that. So we had to come up with a way to convert that data, and we have this utility that we call the VS Terrain utility that allows users to input those types of data files into it and have it be produce a VS Terrain file. So we've improved this tool quite a bit with this release. We've added some custom build settings so that users can modify what we consider, a default case to be more appropriate for the data that they're using. We also improved some of the handling of the mesh data that can be produced by larger programs, so that anything that has a very high triangle budget count or poly counts. Those are more appropriately handled by our utility. We also added command line support, so if a customer wanted to place this utility within their asset creation pipeline or asset management pipeline, they could do so pretty easily. We also, in 2020, added VS Terrain support on most of our HIL platforms. The only one that's missing would be the DS1006. So this allows these VS Terrain files, which are much smaller and much more compact than what you would normally find with a same size piece of terrain defined in FBX. It allows you to deploy those to HIL systems. This is especially useful too when you have Simulink involved. You could potentially run Simulink with VS Terrain connected to external software rendering the scene.
Can we see an animation? The video?
Oh, you're right. I completely forgot. So this is a quick example of a truck striking a curb here, and as you can kind of see, this line here is a average of the normals for these particular curb settings. So the normal is pointed to the it's kind of pointed at a 45-degree angle. This curb was defined in FBX format and then converted to VS Terrain. The solver is then querying the VS Terrain data structures, which it loads at initialization, and then the vehicle strikes the curb as you would normally expect.
What are all those sticks going up?
Those are arrows that indicate the magnitude of the force being applied to the...
No, these sticks?
Oh, these sticks, sorry. These are the normals relative to the ground. So as you can see, they're not all exactly pointed straight up. There are cases where they're slightly curved or not curved, but pointing to the side. Oh, okay. I've been told that the render is a little delayed, so I'll slow down a little bit. So you can kind of see in the back here where there's a transition in the terrain that the normals are kind of pointed to the right for a little bit, and now they're kind of pointed to the left as that transition occurs.
Since there's no coloring that came from this import, it's kind of hard to see the shape. Is there a way to see a wireframe?
Yes. So as you can see, the wireframe is there. These common structure in a tool like these are tri-strips. So you can kind of see the triangles here, being stripped, and those where the normals are coming from. So. We also made some improvements to the scene builder in terms of supporting right and left hand side traffic. So to the image to the right here, I have two different circles. One when the inside loop is being driven counterclockwise, and the bottom is driven clockwise. And that's a simple option in the scene builder to switch between those two types of tiles. Use the same type of path building that you would have done in previous versions. So it's pretty simple to set up something like this. That is part of the right and left hand side traffic is defined in OpenDrive 1.5. So we have supported that particular feature in OpenDrive 1.5. We're still working on some of the more what we consider less used features of 1.5. We'll continue to make improvements with that. Also, the scene builder gained the ability to dock windows. You can kind of see these bars here. You can be able to pull these off and have just this view, just the workspace view on your screen if that's all you're interested in using.
Multiple vehicles. We've ever since we've worked with Simulink, some brave users have made multiple vehicles run under Simulink. You cannot do it from within, say, if we're talking about CarSim. There's no feature in CarSim right now that allows you to simulate more than one at a time. But if you're working under other software, such as an FMU type of FMU type of thing, or Simulink, then you can. And it's well supported, but it's still a little bit complicated. So in this release, Jen Hu, the guy in our real-time and guru for making Simulink connections, made a new screen here. This is the multiple vehicle screen, and it mainly helps manage the stuff. Now I will try to go into that. That would be CarSim, and I'll go to Tools. We have our batch matrix, batch runs, multiple vehicles. Now this is kind of an automation thing. It's not, it wouldn't be an attribute of any single run control thing. Now I look at this, so here's the run setup. The way each vehicle is defined is with a regular run setup screen here. So it's got the vehicle, the procedure. In this case, it's a connection to a Simulink model. We'll go back here. In order to run two or more instances in here, you load two or more DLLs. One DLL, that's the dynamic linked library file in Windows, and it would be what, SO?
Yes.
In on Linux.
Yes.
They all load up, but if they have the same name, it won't work. So in the past, what you had to do is take something like CarSim 32 or CarSim 64 and make a copy of it, call it CarSim 64-1, and then you could run that together. Then you could make another one, call that CarSim 64-2, and run that. This screen does that automatically, or a combination of this screen and a new feature in Simulink, which we have. Normally you would go to Simulink by clicking this button, but it can take a while, so we'll save time. This is Simulink with the environment set up. It's got the 4 cars in here, and when I go, I see here's car 1 that has a bunch of things coming into it, a bunch of stuff coming out of it. This is an icon you haven't seen before. If I go to the library browser, this CarSim S function is the main one that we've had. The camera sensor we've had for a few years. The video we've had for a few releases. This gives you live video while the thing is running. And now there's a new one, multiple solvers. This is the one for car 1. If I look at the one for car 3, very similar, but it's got the 3 on it. So you run the thing from Simulink, and then we can see the results looking at plot setups for any of these data sets that were in there. Oh, this is the platoon one.
This is platooning, yes.
Oh,
yeah.
Sorry about that. We'll go to the active safety one. Here's the active safety one. We saw what it looked like in Simulink. We'll just, is it number 1 I should click?
Yes.
So I can see the video from the camera associated with any of the 4 here. I can see the plots defined for any of the 4. I'll use the first one here.
Takes a second.
That wasn't preloaded?
It was.
Oh.
Okay.
Is the other one preloaded?
I believe so.
Okay. Okay, so I'll stop this a little bit because I know there's a lag with the WebEx. We have a blue car over here. That's one of them. We have a pedestrian walking here. You see the blue beams coming from the blue car. It has sensors in it. These are detection lines. The pedestrian is a possible target. All of the buildings are possible targets. So you see blue line detection lines going to the buildings. You also see a blue line going to this green car. The green car is both a target and another vehicle. In fact, the blue car is both a target and the vehicle. You see the green line going from the green car to the blue car, that is how the green car is sensing the blue car. Now we see blue beams, green beams, yellow beams, and red beams. So these are 4 cars with sensors interacting in a urban environment that came from Scene Builder, running on a 3D ground surface that is represented in VS Terrain. And just for laughs, we have a bicycle also. Okay, now you said there's another one here that has the great. We have another example in here. This one has 5 vehicles. Our video artists added some more assets in here. These little circle numbers that help you identify the cars. So this blue one is vehicle 1. 2, the red car is vehicle 2. They're all in the line here, but this is a platooning example, and it's making use of our driver model that has a preview point. So the blue car is is doing its own thing. I think it's going open loop. The black car is controlling the position of a sphere here that will be used by car number 4. Car number 1 has a blue sphere back here that will be used by car number 2, which is way back here. Car number 2 has one that's behind it that will be used for car number 3. So as the thing proceeds, and we set this up so that the tire tracks are multiple copies are made, so you can see the lines that they're making. So car 3 really wants to get behind car 4. Car 4 wants to car 3 wants to get behind car 2. Car 4 wants to get behind car 3. Is this in slow-mo?
Yes.
I'll jump ahead a little bit. So I've moved ahead. I'll move ahead some more, and you can see that they're settling into this. So the controllers are able. This is a case of using VS commands to position the XY coordinates of the preview point based on the unit in front. So the blue sphere here that my cursor is pointing to is being used by the red car, but it's based on the position of the blue car. And that's how they're all able to get in a line and eventually an even spacing between them. Oops. Ta-da. So this multiple vehicle support is there for Windows and Scalexio real-time from Scalexio from DSpace. The technology is on Linux as well, but we don't have a GUI on Linux yet, so there's not an equivalent screen.
What about licensing?
Oh yeah. The standard CarSim license, CarSim and TruckSim BikeSim license is good for 2 simultaneous vehicles. So both of the examples I just showed you, you would not be able to run from scratch unless you have licenses for multiple vehicles, which is typically done with a network server. If you do, you can rerun them. If you don't, you can see the results. But we also have an example of each one with just 2 vehicles that anyone can run. Unreal. That would be Jeremy.
Yep. So for the 2020 release, we've added the Unreal Dynamics plugin to Linux. We added Linux support. Unreal supports Ubuntu 18, so we built our plugin and our interface for Ubuntu 18. Doing this work required us to update VS Connect and VS Vehicle APIs to also support Linux. So we've upgraded those two APIs for those platforms as well. Unreal has been a pretty important tool for us to work with other development partners, especially those working on different types of LiDAR, radar, and camera models in the Unreal environment, since Unreal provides a much more detailed rendering and capabilities and higher fidelity visualizations. Those companies tend to lean towards these types of tools. So it's been pretty important to us, and we continue to develop it. Also during the previous year, we worked with NVIDIA to become part of their Drive Constellation software stack. So what Drive Constellation is it's a collection of modeling tools and simulation tools that NVIDIA works with and allows to run on their AV testing hardware. And so CarSim is now part of that group. We have a quick demo I can show. So I'm going to pause this at a couple talking points just because I know the WebEx is kind of delayed. So what you're looking at here in terms of the Drive Constellation hardware is on the left you have the DriveSim computer, and then you have the Drive AV computer. And in the computer on the right, you have a NVIDIA Pegasus board, which runs NVIDIA's controls and neural networks, along with capture cards here in the back. And in the DriveSim computer, you have a bunch of graphics cards that are producing the scenes being consumed in this hardware loop. And this video is quickly trying to show what you're looking at the big screen is DriveSim. What you're looking at in the upper corner is Drive AV. Drive AV is running the neural networks to detect the lane edges, provide a path for the driver to follow, and other types of information that it's gathering from the scene. So while running in real time, CarSim outputs can be examined using our tooling. Drive AV can be running. DriveSim is obviously running because we're getting outputs from those computations. Increasing and challenging, night driving is more difficult for perception algorithms. So the demo of the video is attempting to show that. As curvature increases, path planning becomes more of a challenge, lane detection becomes more of a challenge. So those are the types of problems that NVIDIA is working on some of their own autonomous vehicle technologies, and this is part of their stack. For 2020.1, we continue to work with NVIDIA and some of our common customers, and so we'll continue to work on this interface, improve it, make it a little bit more performant, and polish some of the APIs that we've been working on with them. We've gotten multiple requests for CarSim and TruckSim to run on HPC environments, and that lets
What is HPC?
HPC, high performance computing. So large clusters of servers running CarSim in parallel, all consuming data and trying to produce results. So using wide-scale DOE type of testing and those types of things. So licensing those types of environments or architectures has become more of a challenge. So we adjusted some of our licensing architecture to make it easier for customers to deploy CarSim on these types of systems. The biggest change would be is that the customer would run a single VehicleSim license manager alongside the Flex license server on a single node within the cluster or single computer server, whatever the terminology the companies are using. And have that license manager connect with individual nodes, computational nodes that are running the solver. And so this allows the solver to initialize much more quicker, the license checkouts are quicker, and it also allows for a single license configuration to be used when the customer is scaling up or down the number of nodes being used or the configuration of those nodes. Say the nodes switches from 8 to 16 cores or whatever the case may be. A single configuration can be used. So it allows, like I said, a much more easier deployment of an HPC system using CarSim or TruckSim or BikeSim. Part of that initiative too was to become more familiar with Docker. We provide a Linux Docker recipe, and what that is, Docker can be thought of as a way to contain applications. It's sometimes said that it operates like a virtual machine, and from a 10,000 foot view, that's a pretty good analogy. But it's much more lightweight. It's much more self-contained. Thus, where the name container kind of comes from. So CarSim. What the recipe will produce is a Docker container containing CarSim. The customer can then deploy that container very easily to as many nodes as he has control over in his particular data center. So obviously this type of tool would be used in conjunction with the HPC licensing that I just talked about. Part of our recipe is that we added a field where the users can specify a custom location for their CarSim or TruckSim databases, and that allows the users to set up their architecture in a flexible manner. So if that database is stored on a network-attached storage device or other types of storage technologies, they can get access to that relatively quickly. Also, with the 2020 releases, we're working on the VS Visualizer on Linux. So we're a little delayed with this particular product and this development cycle, so we plan to have it done this month. But the visualizer on Linux supports all the rendering features that we have on Windows. Most of the plotting features are supported on Linux. There's just maybe a few different keyboard shortcuts or other things like that that are not quite one-to-one with Windows. We continue to work on this. We'll hopefully have it done, like I said, by the end of the month. And it's also, we're trying to be more compatible with the Linux workflows. The next upcoming phases was we hope to add live animation support, and we know the visualizer is being used in different configurations, especially driving simulators and other types of applications. So we hope to add live animation support in the upcoming release. In 19.1, we released our first version of the VehicleSim SDK. SDK stands for Software Development Kit, and it's meant to make the use of VehicleSim APIs easier, more accessible. In previous, before 19.1, everything was included in the CarSim installation, which made it a little bit more difficult to locate and to get organized. So we gathered everything together, documentation, examples, the actual libraries, the actual binaries, the DLLs, the SOs that the customers would need to develop their own applications around CarSim. With the 2020.0 release, we added, as I mentioned previously when I'm talking about the Unreal plugin, we added Linux versions of VS Connect and Linux versions of VS Terrain, and we also added the BikeSim Modular Solver. So those types of libraries are now there. We continue to make progress on this product. It'll get more feature-rich as versions come out and we get more support for Linux and other platforms. And just a quick summary of some of the Linux support that we've added recently: VS Connect, Train, and Vehicle APIs, Visualizer, Unreal plugin, and Docker recipes. So we're trying to be more friendly to the Linux workflows and trying to work on making those products available on that platform.
So we know what Terrain is, and the Vehicle API we've had for a while. What's VS Connect?
So VS Connect is basically an interface that helps the user set up a co-simulation environment. So it allows for a network connection to occur between, say, Simulink and Unreal, or Unreal and the solver itself, or any other type of connections that way. Most used with Unreal. Let me go back. Most used with Unreal, so say if you had Simulink controlling this platooning example, you had the Eagle vehicle here following this vehicle here, that controller could be in Simulink. The solver for this vehicle could also be in Simulink, this solver for this vehicle could be in Unreal, and you could have a loop made between those two simulation masters using VS Connect.
So you don't need VS Connect unless you have, you're running under two masters.
That's
Unreal
true.
and Simulink.
Yes, I would say that's an accurate statement. Yes. Yep. Some of the partnerships that have come out of some of the SDK products that we have are listed here. So the SDK is pretty important to our development partners, and these types of tooling I'm sure are also available to our customers. And especially, you know, like I said, it makes it easier for our development partners to use our software, and that's what this slide is attempting to show. That's all we have. Is there any questions?
There
Why don't you
are
go back to the
a
previous
couple.
one? Okay.
About the Unreal plugin, can it be used in a real-time setup? The Unreal plugin.
Not currently.
Okay.
Yep. So ideally what we'd like to do in the upcoming releases is have VS Connect be an interface to an Unreal or to an HIL system. The solver would run on the HIL system. VS Connect would be used to transfer outputs from that Unreal system into Unreal, and then the visualization of what's being run in the HIL system would be visible in Unreal.
Are you talking about hard real time and soft real time, or
Yes.
only hard real time?
That would be a combination of HIL, the solver's under the hard timing requirement, but Unreal will always be, well, I won't say always, but is currently only run in a soft real-time environment.
But it's still, if it's used, say, in a driving simulator, without hardware in the loop, just a man in the loop,
Right.
is that sort of real time? No?
Sort of.
Okay.
So sort of. So usually the rule is if you have one thing that's not hard real-time constrained, the system is not hard real-time constrained. But you could argue that the solver
Is
is
it good enough for who
it's
it's
good
for?
enough. Yes. Good enough. Yes.
Jeremy's so technical.
Also, a question about what version of the Unreal plugin is compatible with 2020.0.
4.24.
I believe we have that on our website.
That is correct.
If you go to the user section of the website, there's a compatibility table. So when we release, we try to make it our new version compatible with the most recent Unreal, but backward compatibility is not very good when you're combining these things. So if you probably be wanting to use new versions of both.
Okay. Yeah. I'll answer. We also have another question. Do you plan to build first responder actors? Basically, what the question is asking is, do you plan to build fire trucks, ambulances, and things like that into our asset library? We don't have a plan for that right now, as far as I know.
Yeah, I mean, the vehicle dynamics are
the
physics
same.
are physics.
Right.
And it's, so we can simulate it, but we don't have the artwork for fire trucks and police cars.
Correct.
We can add it to the list.
Yeah. We can. So I think that's all the questions.
Yep, we'll give it just one more minute. If you do have another question, just go ahead and type it into the chat panel. While we're waiting just another quick minute here, we do want to thank you all for taking time out of your day today to join us. And if you visit our website, we have, as Mike said, links to product compatibility tables. The user section has a lot of good resources, and we do have our training and WebEx list for upcoming sessions available. Are we awaiting an electric vehicle powertrain in BikeSim?
That is something we do. So yeah, the question is, will we have electrified powertrains in BikeSim? I think that is something that we have discussed and we hope to do, but I don't know if we have it on the current plan for the 2020.1 release. It's something we are considering, yes.
Yeah, so right now you have to do it with connecting with Simulink or
Right.
with VS Commands.
Right, yeah, that is true. So yeah, if you wanted to do that right now today, you would have to use an external control to be able to do the electrified powertrain. It's not built in.
Okay, well, I think that's it. So once again, we just want to thank everyone for joining us. And Jeremy, Mike, and David, thank you for the presentation. And anything else, please visit our website. Thank you, everyone.